All right. Let's look at velocity. Velocity. And please, speed is a scalar quantity. Speed is a scalar quantity, meaning that with speed, we only talk about the magnitude and do not associate direction to it, right? Velocity. Yeah, somebody to help me. Agosia.
Mr. Jen, it's a question on speed.
Okay.
She said it's a scalar quantity, but with speed, like anything you do with speed is not in a direction, like running with speed.
When you Usain Bolt, the fastest man then on earth, okay, is involved in athletics competition, all that you will need is give me a distance of 100 meters, and he would, after timing him, you will get his speed. Usain Bolt will never care about the direction of the distance. Just give me a distance of 100 meters. And I can prove to you that I'm going to use a smaller time to finish this race than anybody else. Are you okay?
Yes, please.
So here, the interest is on the quantity, that 100-meter distance, and doesn't care about which direction it is. All right?
Yes, please. Thank you.
Okay. So velocity. Velocity. Yes. Bushra, are you there? Hello, Bushra.
Yes.
Yes. Tell us something about velocity. What is it?
Yes, please.
Just tell us what you know, okay, about the term velocity. What is it? What is velocity?
Velocity is the change of.
Yes, you're on the right path. Go ahead.
Is the change of.
Okay, we shall refer better and then come stronger next time. Okay, so let's have Yaba. Yaba, it's your turn. What is velocity?
Velocity is the rate of change of displacement with time.
Okay, so the rate of change in displacement with respect to time. All right. Bushra, did you get that?
Yes, please.
The rate of change of displacement with time. So how distance covered in a specified direction, okay, changes with time. Assuming Miss Abia is running, okay, within 1 second, running due north. So I've specified the direction. Okay. Give me a second, I'm coming. Okay, right. So I'm running due north. Okay, so within 1 second, the distance I've covered is maybe 1 meter, another second, 2 meters, 3, 4, 5, and so forth. So when there is a change in the displacement or speed in that specified direction with time, that ratio is equal to what we are saying as what? Velocity. Are we fine?
Yes.
So this is the rate of change of displacement with time. This is the rate of change of displacement with time. Some books will use with respect to time. Okay, these are just English. Now the SI unit of displacement is the same as the SI unit of speed. So, what is the SI unit of speed? Then we talk about SI unit of velocity. What's the SI unit of speed, Bushra? Oh, she has gone off. Alexandra.
Meter per second.
Good. So the SI unit of velocity is the same as the SI unit of speed, meter per second. In fact, magnitude-wise, in terms of magnitude or amount, speed and velocity are the same. They both have the same magnitude. Okay, so a speed of 10 meters per second is also equal to a velocity of 10 meters per second. But for velocity, we often specify the direction. For speed, all that we say is that, oh, the magnitude is 10 meters per second. But for velocity, we will describe it as, oh, the velocity is 10 meters per second due north, due south, due east, to the right, to the left, or to an angle of 30 degrees, 45, we add direction. But in terms of magnitude, they are the same. That is why they have the same units. All right. And they also have the same dimension. They have the same dimension. Okay. Velocity is LT to the power -1. Speed is LT to the power -1. All right. Acceleration. Equia.
Acceleration refers to the rate of change of velocity with time.
Okay, so the rate of change of velocity with time or with respect to time is equal to acceleration. So maybe in the early morning of the day, you just jump into your father's car. When you are taking off, obviously you can't speed at home. Okay, so daddy will take his time to drive, okay, leave the compound. But look at what is happening. When you sit in the car, daddy sits in the car, the engine gets started. What is the velocity of the car? Or what is the speed of the car?
0.
0. Now, in moving it, daddy will slowly step on the accelerator. By stepping on the accelerator, what he's doing is that he's increasing the speed a little bit. Okay. Then when he joins the main road and there's no traffic, he can increase the speed. So what are we seeing? We have an increasing velocity from 0 to a certain amount, to a certain amount, to a larger amount within a changing time. So when the speed or the velocity of a body is changing, the change has to be an increasing one. And with time, when the velocity or the speed is increasing with time, it gives birth to what we call as acceleration. So every acceleration has to do with a changing speed. And the changing speed has to be an increasing speed with time. Are we fine?
Yes, please.
Yes, please.
Yes.
That is why we explain acceleration. Or it is defined as the rate of change of velocity slash speed. It's either velocity or speed. I said that in terms of magnitude, they have the same value. So sometimes, in most cases, we use them interchangeably. Okay. Meaning, for here we overlook the direction and then consider the magnitude. So the rate of change of velocity or speed with respect to time. So mathematically, this is how we express it. Acceleration A is equal to delta V on T, where delta V is equal to change in velocity. So a final velocity V minus an initial velocity U, all divided by time, would give you acceleration of a body. When we begin to solve questions with this, you appreciate it so much, okay?
Yes.
All right. Let me call somebody to help me get the SI unit of acceleration. And I'm going down. Stone boy. Stone boy. Oh, it's a stone girl. Hello, stone boy.
Yes, sir.
Oh, it's a stone girl. Okay. What? Help us obtain the SI unit of acceleration. Are you there? Okay. Whilst she's engaging the brain, let me have somebody else to come in. She's thinking through it. Tracy, have a view. Tracy, I've traced you. Tracy. That's our unit of acceleration, Tracy. Oh, Tracy, I can't hear you. Oh, rather unfortunate. She's talking, but I cannot pick at my end. Okay. Anybody to help us derive the SI unit of acceleration? Okay.
Meter per second square.
Okay. Okay, so the SI unit is this. Look at it. Velocity is, the SI unit of velocity is meter per second. The SI unit of time is second. So in our indices, we have meter per second divided by second. If we bring this up, we have, if we bring the S as a denominator up, we have meter per second times per second, isn't it? Isn't it? And so we have meter per second squared. Or sometimes you write it as meter per second squared. Either you write it in this way or in the other way. So that's the SI unit of acceleration. It can also be given to you as kilometer per hour squared, kilometer per minute squared. Let's quickly go through something. I want to give you a value in other units, and let's see how we can convert, okay? So maybe the velocity of a body given to you is 25 kilometer per hour. Convert this to SI units. We are to convert a velocity of 25 kilometer per hour to SI units. Start work. Let's see what you can do. Finished? Hello? Who is true? No one. Agusia, what did you get?
6.94 meter per second.
6.94.
94.
So Akosia had 6.94 meter per second. Okay, who else? Lauren, go ahead.
Please, I also have 6.94 meter per second.
Okay, so let's look at it. Let's look at it. Let's solve it together. So I have 25 kilometer per hour. This is equal to 25 kilometer divided by 1 hour. That is what it means. So I convert 25 kilometer to meter, and then I convert 1 hour to seconds. So 25 times, you see, the letter small k is a prefix. It's a prefix. It means we have 10 to the power 3. Kilo means 10 to the power 3. Micro means 10 to the power -6. So learn these prefixes. Okay, so this kilo means that we have 10 raised to the power 3, then m, meter, divided by, I know 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So it implies that 1 hour is equal to 60 minutes times 60 seconds, which will be 3,600 seconds. So this is equal to 3,600 seconds. And so I have 25 times 10 to the power 3 divided by 36 times 10 to the power 2. What do I have? I have 25 over 36 times 10 meter per second. Now you divide 25 by 36. What is 25 by 36?
0.694.
0.694 This is times 10. So times 10, I shift the decimal place 1. So I have 6.94 meter per second. All is well. Are we fine?
Mr.
Yes,
Ja,
please. Yes, please.
Mr. Ja,
Hello.
is when you're solving it, is it compulsory to do it like this, like 10 exponents? Is that how we are
Oh.
expected to do it?
That is one way. You can
Okay.
also use your method. Okay. I'm
Yes.
sure this is your method because 1,000 meter is to 1 kilometer. Okay. Now you have 25 kilometer. If one is giving you 1,000, 25, will it be more or less?
More.
More. If more,
Let's divide.
so that is the idea. Okay, so you end up, this will simply be 25, okay, times 1,000, which is the same as this.
I see.
Now, let's look at it from the other side. Maybe you are given an acceleration of 4 meters per second squared. Convert to kilometer per minute. Convert per minute square, sorry. An acceleration of, let me give it to you as velocity. You have a velocity of 4 meters per second. You have to convert this to kilometer per minute. Let's see how you go about it. Start work. Because you are finished.
Yes, please.
What did you get?
0.24 kilometers per minute.
0.24 kilometer per minute.
Yes, please.
Okay. Yeah, but what did you also get?
He's also got 0.24 kilometer per minute.
Okay. Stoneboy. Stoneboy,
Yes, sir.
what did you get?
So I also got 0.24 kilometers per minute.
Okay, let's see. So it means we have 4 meters divided by 1 second. That's what it means. Okay. So we'll convert 4 meters to kilometer 1 second into minutes. But we know 1,000 meters is to 1 kilometer. And 1,000 meters is actually equal to 1,000 times 1 meter. 1,000 meters is 1,000 times 1 meter, right? So if I'm to obtain the kilometer equivalence of 1 meter, it means I have to divide this side by 1,000, and so it will be 1 kilometer over 1,000. What it means is that 1 meter is equal to 0.001 kilometer, or 1 over 1,000. Are we fine?
Yes, please.
Yes, please.
Good. So if I have 4 meter, 4 meter will be equal to 4 times 0.001 meter. Kilometer. So 4 meter will be equal to 4 times 0.001 kilometer. That is it for converting the numerator. Let's come to the denominator. 60 seconds is equal to 1 minute. Please, I'm coming in. Let me pause and then quickly.
Yes.
So 60 seconds is equal to one minute. Therefore, 60 times 1 second is also equal to 60 seconds. So if I'm looking for 1 second equivalent of meter, I have to divide through by 60. So it means that it therefore means that 1 second. Let me change the marker. 1 second is equal to 1 over 60 minutes. Okay, so divided by, we found 1 second in minutes. And what is 1 divided by 60? Do that for me. 0.016. 0.0167 minutes. So multiply the numerator by 4 times 0.001 and then divide it by 0.0167. So 0.004 divided by 0.0167. What did we get?
Zero point 24.
24 kilometer per minute. So please, and I did this systematically to help us to understand. Okay. I took this systematically to help us understand. So when you are free, just give yourself questions. Give yourself question from maybe a question in kilometer per hour per minute convert to SI unit, and give yourself a question in meter per second convert to kilometer per minute, kilometer per hour, kilometer per day. In doing that, you are mastering how to convert. Is that okay?
Yes.
All right. Any question? No question. So we were on acceleration. Let's quickly look at a deceleration. So we are looking at motion in one dimension, one-dimensional motion. What do we mean by deceleration or retardation? When a body is decelerating or retarding, what do we mean? What do we mean to say a body is decelerating or is in retardation? Alexandra. Alexandra, go ahead.
I think it's the decrease in velocity per unit time, or it's the decrease in velocity in respect to time.
Okay. Good. I think that has been said. So if a body is moving at a top speed, no matter how speedy you can be moving with, being it a car or you, when you are getting home, you definitely reduce speed. You can't be moving with that top speed to your home. All right. So when the body attains a maximum speed and decreases it gradually from the top, from the maximum speed, maybe let's assume 10 meters per second squared, 10 meters per second, sorry, velocity, reduces the velocity from 10, 9, 8, 7, 6, okay, to when the body comes to a stop or come to rest. Okay, so the rate at which the velocity decreases with time is what we call as deceleration or retardation. So deceleration or retardation is also a kind of acceleration, but a negative of it. Okay, acceleration is considered to be a positive value. As positive because with acceleration we are talking about, because it's about an increasing velocity, the final would always be greater than the what? The final will always be greater than the initial. Okay, so v, which is the final velocity, minus the initial velocity divided by time will give us acceleration. But because v is a larger value, v is greater than u, you have acceleration to be a positive value. So this will give you a positive value because v is greater than. Now, deceleration or retardation is negative because look at the example I stated. A vehicle is moving at a top speed to the house. No matter how speedy your car can be, you can't enter your house without speed. You have to reducing speed till you get home. By the time you get to the house, your final velocity will be what? The final velocity is 0. So over here, look at the final. V is 0. Initial is huge. The starting velocity is large, but the final velocity is 0. So because this is 0 and this is a large figure, when you divide, you tend to have a negative value. So that's why acceleration is a positive situation, but a deceleration or retardation is a negative situation. Any question? No question. Or if you have any question, quickly ask and let's continue. So this is anything about a body in a linear motion. The distance, which is just the interval between 2 points in a straight line, Then the displacement, which is the distance covered in a specified direction. Okay. Then we can talk about the body's speed, which is the distance covered over the time taken. Florence, Abba, go ahead.
Exactly the equation for the deceleration.
Mhm.
What's the first letter there?
Is it this?
Yes, and then after the equal to,
This is A. I'm using,
and then after the equal to sign.
this is 0 minus U. 0 because the final velocity is 0. The body has come to a stop.
Yes, please.
When a body comes to a stop or rest, its velocity is 0. Yes. Please go ahead and ask your question.
Please, the letter acceleration, the one which is positive, please, what's the letter in the bracket?
Oh, A. It's A. I'm using the letter A for acceleration. Okay. I go to every year.
Mr. Dia, please, can I get a definition for deceleration?
You see, Akosha, deceleration is also acceleration, but this one